All right. In this next video, we'll be talking about the okay. We're talking about the matrix multiplication. Matrix multiplication. This involves the row times column function. That is, what we are saying is that when you want to deal with matrix multiplication, how do you come about that? It's the law states that row R multiplied by column C column C to give what? It's going to give you row, which implies that row, or let me just say, let this row be capital letter R, and this one to be capital letter C, and this capital letter R. What we are trying to say is that if you have row multiplied by column, it's going to give you what? Row. Alright, that's the logic. Row times column will give you row. Now let me explain that. Suppose that A is equals to this: A11, A12, A21, A22, and B is equals to this: B11, B12, B21, B22. Alright, so we are told to find C. We are told to find what? To find C. So we just want to show that the product of this and this is going to give us C. Find C whenever A times B is C. So suppose A equals to this and B equals to this. So find C whenever A times B is equals to C. It's going to give us C. So right now, so how do we go about it? Let C also equals to what? C11, C12, C21, C22. So which means that we want to find the individual element of C. So when they now get the individual element of C, they will now input it back. That is what they ask us to find. So, but we can only achieve that by multiplying this guy and this guy. That is A and B. That's the only way we can achieve that aim. The only way we can achieve the aim of getting the result or the element of C is by producing what? The A and B. Now here we go. A times B. What is A? A11, A12, A21, A22 times what? B11, B12, B21, B22. Alright, so let's solve the problem. Now the rule states that row times column will give you what? Column. Now it means that this first row in this first one, this is the one that begin it. So what's the first row that we have here? This is the first row here. So the first row here will multiply the first column here to give us row. Are we together? The first row here will multiply the first column here. The first row in this place, we are going to multiply the first row here with the first column here to give us row. We will repeat the same process for everything. So let's start with this one first. Yeah, now this first row and the first column. So now from the first row, what's the first element? A11. From this first column in this second matrix, what's the first element? B11. We have the first element from the first row times the first element from the first column in the second set. Now go AB is equals to this first row times this first column, A11 times B11, A11 times what? B11 plus, it's plus that you always put there. This one times this one plus this one times this one. That is the second element of first row times the second element of the first column. So the second element of the first row is A12 times what? B21. Do we get it that way? So we're done. Alright, so now we clean this one, we move to the second column. We are still using this one until we are done using this one to multiply. We use this one to multiply the first column of this, second column of this. This first matrix, we use it to deal with the whole of this. How? The first rule of this first matrix, we use it to multiply the first column. This same first rule, we use it to multiply the second column. Then when we are not done, we now move to the next one, second rule. But we are not done with using the first rule of this matrix. So this first row, we are done using it to multiply the first column here. So let's use this same first row to multiply the second column. This is very easy. So this is the second column. So I don't want to mix it up. Alright, so here we go. A11 times B12 plus A12 times B22. A12 times B22. I think we are done. No mistake. Alright. We are done with using this guy. Now let's move to the second row of this first matrix. So we'll do the same thing for this second row of this matrix. We use this second row to multiply the first column of this matrix. Are you with me? This same second row, we are still going to use to multiply the second column to give us a row. You can see that as we are getting the result, we are putting it in a row. That's what we mean by it's going to give us a row. So this first one multiplied by this first one, that is A21 multiplied by B what? 11 plus A22 B21. Now we're done with this guy here. We're done with this guy here. We're done with this guy here. So let's use the same one to multiply this last. We want to go this last time. We have B22. Alright. A21 multiplied by B12 plus A22 multiplied by B22. Abi, that's it. So we are done. So now this one gives us A11 B11 plus A12 B21, A21 B11 plus A22 B21. Then this one is what? A12 B12 plus A12 B22. This one is what? A21 B12 plus A22 B22. So therefore our C is equal to the result of this. So our C now is the result of A times B. So that's A11 B11 B12 B21, A21 B11 plus B22 B21, A11 A12 B12 plus A12 B22, and A21 B12 plus A22 B22. So that's it. Then we conclude that the function row times column to give row is satisfied for a given multiplication matrix. So we have proved a matrix out. We have already proved this matrix out. Now let's solve a problem. Let's solve problem of multiplication of matrix. Question 1. Given that A is equals to 3112 and B is equals to 5513, find AB, that is A times B. BA and hence also find BA minus 2A. Let's solve this problem. Plus I. So solution. Good. Let's solve I. AB now. What's A? Our A is 3, 1, 1, 2. Then our B is what? 5, 1, 5, 3. Right? So let's solve it. Don't forget, row times column is the formula. What's the first row of this first matrix? This is the first row. What's the first column here? This is the first column. Yeah, let's start. This is the first row, this is the first column. What's the first element of this first matrix? 3. Have the what? 3 times the first one here times the first one here. 5 plus 1 times 1. Alright, we're done. We are still using this rule until we use it to multiply this. We are expanding. Yeah, 3 times what? Times 5 plus 1 times 3. Right? So every result will be placed in the row side. So we are done with this guy. So we are using the second row now to multiply, to expand everything here. So the first column. So 1 times 5 plus 2 times 1. Then we are done with this first column. Move to the next one. 1 times 5 plus 2 times 3. That is, we are going to be having what? 15 plus 2. 15 plus 3. This one is 5 plus 2. 5 plus 6. Right? So we are having what? 17, 7, 18, then 11. So this is our results for this. So now let's solve this number 2. Let's solve this number 2. Let's solve for number 2 now. Number 2, BA. So what do we have? Our B is 5, 1, 5, 3. Right? And our A is 3, 1, 1, 2. Alright, what's the first row? 5, 5. The first column, 3, 1, 5. Now the first row times the first column will give us this first row here. So 5 times 3. 5 times 3 plus, this is the first row. 5 times 3 plus 5 times 1. Now we're done. We want to multiply by the second column now. 5 times 1 plus 5 times 2. Now we're done with this first row. Row times column is the logic, don't forget. Now the second row to multiply the whole of this. Let's start with the first column. 1 times 3 plus 3 times 1. Then let's go to the next column. 1 times 1 plus 3 times 2. Okay, we're almost done. That will be equals to 15 plus 5, 5 plus 12. This one is 3 plus 3, and this one is 1 plus 6. That is 26, 17, and 7. Alright, so that's our answer. So let's move to the last one. 1, 2, 3. So we're having what? BA plus 2A plus I. So now, what is BA? We have already solved for BA earlier. This is BA that we solved for. This is the result. So it implies 26, 17, 7. We have already solved for this before. Then 2 into, what's the value of A? 3, 1, 12. 3, 1, 12. Right? Plus I. This is I. I means identity. Identity. So our identity for matrix is always 1, 0, 0, 1. This is identity expression. Anytime you see how you put this. So now we now have that. This is a scalar matrix, so we have to expand this. 20, 17, 6, 7 minus. You use these two to expand everything because it's a scalar. This one is 6, 2, 2 times 1, 2. This is 4 plus 1, 0, 0, 1. Okay, so now let's begin to solve this question. So that will be 20 minus 6. 20 minus 6. I want to deal with this one first. 20 minus 6. 17 minus 2. 6 minus 2. 7 minus 4. Plus 1, 0, 0, 1. So this one is now 14. This one is 15. This one is 4. This one is 3 plus 1, 0, 0, 1. So that will going to be 14 plus 1. 15 plus 0. 4 plus 0. 3 plus 1. Right? So at the end of the day, 14 plus 1 is what? 15. 15 plus 0 is 15. 4 plus this is 4. This one is 4. So that is our final answer. That is our final answer. So that is all about multiplication of matrix. So I'm going to be giving us a classwork. This short classwork. If A is equals to 1, 3, 1, 4, 6, 5, 7, 1, 2, and B is equals to 2 minus 1, 4, 5, 3, 6, and minus 2, 4, 5. Find AB, BA, and 2BA plus I. So solve that. Solve this guy and put your comments in the comment section. And can I add one for you? Sorry, let me add one. BA minus AB. Drop the question, drop the solution in the comment section. So I love you guys. Thank you for understanding this. So the next video we are going to be talking about transpose and inverse of the matrix. We use that one to bring the matrix to conclusion, because most especially the inverse used to come out every year in JAM. You can't escape it. It comes out very, very well in JAM. So before you can be able to solve for inverse, you should be able to find your cofactors, individual cofactors, transpose, and you should know your determinants. So we are going to do determinant, transpose, and inverse. You have three left. All right. Thank you. I am Elite.